Hello students. So in the last class we have seen the introduction of the derivative part. Now we'll study some different types of functions. For them we are going to find out the derivatives. Okay. So among that the first one I have taken, that is derivative of composite function. Derivative of composite function. So let me explain first what is meant by composite function. So composite means what? It is the combination of the functions. Combination of the functions. So it may be the combination of two or more functions. Okay. You may get the combination of two functions or the combination of three functions. So such functions are called as what? Composite functions. So for such functions we are going to find out the derivatives. Okay. And this concept is important as per the examination point of view for 1 mark. Okay. So for 1 mark question, most probably you may get the derivative of composite function. Okay. So let us solve some of the examples here. So you will get the question is what? Differentiate the function with respect to x. Differentiate the function with respect to x. So let us take the first example. Y is equals to sine of x square plus 5. Y is equals to sine of x square plus 5. So this is called as composite function. So it is made up of two functions. One is sine, that is trigonometric function. X square plus 5, it is a polynomial function. So it is made up of trigonometric and polynomial. Okay. So we have to differentiate this. So we have to differentiate with respect to x. Okay. Now derivative of y with respect to x is dy by dx. Okay. So y is a function here. So derivative of y with respect to x is what? Dy by dx. Next, how the function is given? Sine of x square plus y. So while reading, which function comes first? Sine. So you know, sine of x square plus y. So while reading, first function comes is sine. So first we have to take the derivative of sine. Okay. So you know, derivative of sine x. Derivative of sine x is what? Cos x. Derivative of sine x is what? Cos x. But keep in mind here what we have this x angle. In the place of that x angle, now we are having what? X square plus 5. Now we are having is what? X square plus 5. So when you take the derivative of sine, okay, see here, sine x derivative is cos x. This x we have kept as it is. Here also the same. Derivative of sine of x square plus 5 is what? Cos of x square plus 5. Cos of x square plus 5. That angle we have kept as it is. Into we have to take the derivative of second function. Derivative of second function. That is, what is the derivative of x square? Is 2x plus 5 is constant. Derivative of constant is 0. Okay. So which is equals to cos of x square plus 5 into 2x plus 0 is 2x. So this is your derivative. This is your derivative. Okay. Next example. Y is equals to cos of sin x. Y is equals to cos of sin x. So again you write differentiate with respect to x. Now derivative of y is dy by dx, which is equals to, now while reading, how you read this? Cos of sin x. So first function comes cos. Okay. So what is the derivative of cos x? Minus sin x. So minus sin x. X is what? The next function. That is sin x into derivative of second function. Second function is sin x. Its derivative is cos x. Its derivative is cos x. So this is the answer. Okay. Third question, y is equals to sine of ax plus b. Y is equals to sine of ax plus b. So again you write differentiate with respect to x. Now derivative of y is dy by dx, which is equals to, now this is sine of ax plus b. So first we have to take the derivative of sine. So derivative of sine x is cos x, but x is what here? Ax plus b into now second function derivative. To this x, this a is multiplying. A is a constant here, but don't write the derivative is 0. So whenever any constant, if it is multiplying to the function, or can say to the variable x, and that constant we have to keep as it is into derivative of x. So derivative of x is 1, okay, plus, now it is b. B is again a constant, but this b is purely constant. In that there is no any variables present, or there is no any function is present. So therefore derivative of this constant is 0. Now dy by dx is equals to, okay, so this is cos of ax plus b into a into 1 a plus 0, it is a. It is what? A. So this is your answer. Okay. Let us take next example. Y is equals to sec of tan of root x. Sec of tan of root x. So again you write differentiate with respect to x. Okay. Now when you differentiate this, see, it is a combination of how many functions? 3 functions. So first we have to take the derivative of sec. So what is the derivative of sec x? That is sec x into tan x. Okay. So derivative of sec x is sec x, but x is the next function. That is tan of root x into tan x. It is tan of root x. Okay, sorry, tan root x. Okay, now next into next second function is tan. Its derivative is, I'll write it below, sec square x. That is x is root x here, into third function is root x. Its derivative is 1 upon 2 root x. 1 upon 2 root x. Okay, so this is the derivative here. Now next example, I will solve some more examples. Okay, so to get the idea of the derivative of composite function, that is y is equals to sine of cos of x square. Sine of cos of x square. So this is the composition of 3 functions again. So derivative of y is dy by dx. So first to take the derivative of sine x is cos x. X means the further function you have to keep as it is, cos of x square, into second function is cos. Now derivative of cos x is what? Minus sine. So minus sine x. X means second next function, that is x square, into third function is x square. So what is the derivative of x square? It is 2x. X square derivative is 2x. So this is your answer. Okay. Let us take some more examples in this composite function. Y is equals to cos x cube into sine square x to the power 5. Okay. Now here, this is the product of 2 functions, product of 2 composite functions. See, this is one function, this is one function. This is composite function, even this is also composite function. But this is first, this is second. So here we have to use the product rule. We have to use the product rule. So in the last video, I have given the product rule. What the product rule says? First function constant, derivative of second, plus second function constant, derivative of first. That is the product rule. Okay. So here y derivative is dy by dx. Now here first function I will keep constant, that is cos of x cube, it is constant. Take the derivative of second function. Now this is sine square of x to the power 5. Okay. So here first we have to take the derivative of sine square. What is the derivative of x square? 2x. Like that, derivative of sine square is 2 sine x. X is what? X to the power 5 into. Now take the derivative of sine function, that is cos of x to the power 5 into x to the power 5 derivative is 5u x to the power 4. 5u x to the power 4 plus now second function is constant, that is sine square of x to the power 5 is constant into a derivative of first function, that is cos of x cube. What is the derivative of cos of x cube? Minus sine of x cube into x cube derivative is 3x square. X cube derivative is 3x square. So the solution is little bit lengthy compared to the previous questions. Now you just simplify this. So see here 2 into 5, it is 10 x to the power 4. This is cos of x cube. Next, cos of x to the power 5 into sine of x to the power 5. I have rewritten the solution once again. Here plus into minus 3x square I have kept first. Then next sine square of x to the power 5 into sine of x cube. So this is your answer. This is your answer. Little bit complicated. Okay. So this we have solved with which rule? Product rule. Okay. So let us take one more question. One more question. In that example, I am going to use the quotient rule. I am going to use the quotient rule. Okay. So quotient rule, what it says? Denominator square, then denominator constant, derivative of numerator minus numerator constant into the derivative of denominator. That is the quotient rule. So let us take that one example. Based on that, y is equals to sine of ax plus b divided by cos of cx plus d. Cos of cx plus d. So here y derivative is dy by dx, which is equals to, we have to apply the quotient rule. So just now I said, what is the quotient rule? Denominator square. So it is cos square of cx plus d. Okay. Now denominator is constant, that is cos of cx plus d into derivative of numerator. So what is the derivative of sine of ax plus b? That is cos of ax plus b into second function derivative. X derivative is 1, 1 into a it is a, plus b derivative is 0, minus now numerator is constant, sine of ax plus b is constant into derivative of denominator. So denominator is what? Cos of cx plus d. So cos derivative is minus sine of cx plus d, minus sine of cx plus d into inner derivative. X derivative is 1, 1 into c plus d derivative is 0. Okay. I will just simplify for one more step. So here cos of cx plus d into cos of ax plus b into a plus 0 is a. Now here this minus it get plus sine of ax plus b into sine of cx plus d into c and divided by cos square of cx plus d. So this is your answer. Okay, so here mostly I have solved all the different type of questions in this composite function. Okay, if anyone is left or it is there in the notes, please you copy it or you just go through it once again. Okay, thank you.